Hey guys, what's up everyone? Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education, where on my channel I primarily focus on helping CSEC, CCSLC, SEA and CAPE students with mathematical problems, questions, past paper questions, and like for example in this video we're going to be talking a little bit about circle theorem, one of the most problematic topics when it comes to math at the CSEC level. All right, and more so it has a lot to do with Euclid geometry. So if you understand like the basic forms of angles, then everything is just really kind of tying in the concept of angles, where angles are created within a circular boundary. Alright, but without further ado, if this is the first time here on the channel, consider smashing the subscribe button below, turning on your post notification bell to be notified on a weekly basis whenever I post tutorial contents. And you can leave some comments in the comment section below. Leave a like and share this out to your math communities. Alright, so in this particular video, we're going to be looking at a concept known as circle geometry. And I'm gonna try to keep this content related to like an hour, so this will suffice for most students study time of an hour of practice. So if you're watching this video, you could consider this as a practice session where I'll be walking you through some basic concepts related to geometry. So for this particular upload, I'm going to be explaining some concepts, doing some questions related to that particular concept. And then in another upload, I'm going to be applying all the concepts we learned in this video in the next video by working some advanced questions. All right, so I know that this is a very problematic topic for you all, so let's get right into it. All right, so as you can see here on the screen, I have some information brought up here, and it says that circle geometry is the sub-branch of geometry that governs the theorems related to angles that are formed within a circle. All right, so everything that we're going to be discussing is as it relates to angles within a circle. Now, many of the theorems that are correlated and are stemming from the basic geometric properties of intersecting lines, triangles, and quadrilaterals. All right, so you're going to see various types of shapes being created by these lines, and with these shapes, they will be angles that are affiliated with them. All right, now circle geometry will disclose 13 angle theorems, 13 rules, very basic rules, most so than not, but it's more like, it's theorems that have been proven in other aspects of math. So it's not just for the circle, but it's related to other areas, hence why we call it a theorem. It's not been proven otherwise. Now, that is related to corresponding to the circle. But first, we're going to look at some special lines that you're going to see oftentimes being drawn in the circle, and how the theorems, the angle theorems, connects to these particular lines. Now, the very first thing here that I want to introduce to you is what is known as the radius. All right, plural form radii, that's R-A-D-I-I. Now it says here by definition, my definition, that is that the radius is the line that is drawn from the center of the circle, and from that center point, once it touches any part of the circumference, then we define that as being the radius. All right, now regardless of how much radii may be drawn within the same circle, the length remains congruent. All right, it means that the length of all the radius that is drawn within one circle will have the same, or will have the exact same measurement. All right, the next line that we're going to be looking at is the line that is connected to the radius. By extension, it's called the diameter. All right, the diameter. And the diameter basically by definition says that the diameter is a line that is not just drawn to touch the center of the circle, but is drawn through the center of the circle to touch any two parts on the circumference. The diameter is regarded as the longest chord of the circle. All right, later on we're going to be looking at what is a chord, but you're going to find here that the diameter is going to be the longest of any chord that you may see be drawn in a circle. All right, and which it creates basically two segments of the circle. All right, so then if the diameter goes through the center, then you have a half segment at the top and a half segment at the bottom or to the side and side. Okay, now there is a relationship between the diameter and the radius. And this is not necessarily for students who want to study the history of math, but this research has been done a long time, and so just giving you what is necessary for you to know related to the circles is that the relationship between the radius and the diameter is that the radius and the diameter implies that the radius is half the distance of the diameter, and or you can say that the diameter is twice the length of the radius. Right, and we use common D to represent diameter, and we use common R to represent radius. All right, we're gonna go on next then to we're gonna be looking at the chord. So the chord is the line that is drawn to touch any two parts of the circumference. The chord tends to create two segments of the circle, which, as I said, there's a tutorial related to areas formed by sections in a circle. So the chord basically creates what are known as segments. Segment 1, segment 2. You may have half and half, a quarter and 3/4, 2/3 and 1/3, whatever the case may be. All right, so those are called segments. I tend to always say that they looks like a slice of melon. That's what it really looks like. The segment is like a slice of melon, right? A slice of two-dimensional melon, all right, which is a circle. So next line here is the tangent, and the tangent is the line that is drawn to touch the circumference without cutting it. All right, the point at which the tangent touches the circle is known as the point of tangency, or you're going to find most in formula books that the point of tangency is also called the point of contact. All right, so this particular line brushes the circumference, doesn't create any parts or doesn't cut it, it just slides past and it goes on its way. All right, so with that information, then you can see here that all that information now is really what's going to be used to set us up for what's coming, because a lot of persons are trying to swap the techniques that are needed to solve a circle theorem questions. The reason why majority of students will struggle with problems like these is because the fundamentals of understanding geometry was not set. Once we know the different types of lines, we know how to identify them, we know how to identify the regions created by them, and we understand the very basic fundamentals of what makes the circle a circle, then it means that each and every explanation, each and every theorem is just going to be connected some way, somehow back to that fundamental principle. Now that we have discussed theoretically and verbally what these are, let's actually visualize these lines on a particular diagram here. And let us first start with the fact that the circle has a center, and that center in this particular diagram is labeled M. All right, traditionally at this level, we really identify the center of the circle with the letter O. That's what we usually view it as. So once you look in any formula books, any textbooks, any past papers, any exam papers, you're going to find a lot of the times, unless it's for a specific reason, you'll oftentimes see the center being labeled O. All right, and as I said before in the definition, this yellow line here pretty much confirms that that's what the radius looks like. It's a line that is drawn from the center to the circumference. All right, and we have one here and we have one here. Okay, so that's the radius. And notice now that the pink line that's going through the center here is known as our diameter. All right, and basically it is also called a chord, right? A chord. That's why I've labeled also the chord in pink, because I want to make a correlation between the fact that the diameter is also called a chord, but it is in fact the longest chord of the circle. All right, now the chord, as you can see here, it doesn't go through the center, right? It just pretty much is a line that is drawn anywhere within the boundaries of the circle, and as long as any two edges of that line touches the circumference, then that line is regarded as a chord. Hence why the diameter is just a line. It just specifically goes through the center, but it's also a line that touches any two parts of the circumference. All right, and then now we have the tangent. The tangent is just basically a line that just basically comes here and it touches the circumference, but it really doesn't cut it. It just passes through and goes on its way, and that's the tangent. All right, and this additional line here, which we did not discuss theoretically what the secant is, but the secant is basically like an extended chord. Okay, so the secant is a line that passes through any two parts of the circumference. All right, it goes through. It doesn't stop at the edge. It goes right through to maybe some imaginary point that's lying out in space. Hence we call that is the secant. All right. All right, so pretty much that's the diagram that really governs the circle. As you can see here, because of those lines, you have regions being formed, and we're going to figure out what these regions are called. All right, one additional information here is that around the edge of the circle is called the circumference. Okay, the circumference, or you may oftentimes hear they say find the perimeter of the circle, which is the same thing as the circumference. All right, and here I told you earlier that it is also called the point of contact, but advanced textbooks will say that it's called a point of tangency. All right, so let's just get familiar with the basic concepts there. All right, so for this particular video here, all right, this is what I'm going to be, I'm not sure what I'm going to call this video, but I'm going to end the video here now, guys, and this is just part one. I'm going to be titling this here the introduction to the basic concepts of circle theorem. All right, so I'll see you in the next video, guys. Here what you're going to see are me discussing 13, or for the next video I'm going to be discussing 7 of those theorems in depth. So get ready, let's go, and I'll see you in the next one. Take care, bye.